Oh, all right, welcome back. And this is the continuation of Form 1 marking scheme, Corona holiday worksheet, right? Question number 15. This question is about number sequences, what their nth terms could be. All right, write the missing information in each table. First 4 terms of the sequence is given, and the nth term is also given, 3n. Now the question is, you are given this sequence. Let me show you. You are given this sequence here. You have 4. Let me write it here. You have 4, comma. You have 7, comma. You have 10, comma. You have 13. And the sequence keeps on going. Now, what is the nth term? Now, the nth term is easy to be found. You just look for what we call term to term rule. See that? Term to term rule. Now, what is the term to term rule here? From 4 to 7 is add 3, 7 to 10 is add 3, add 3. So the term to term rule is positive 3, meaning add 3. Okay, so we use the term to term rule to generate the nth term. How? Just look at here. The first number here is 7. In other words, to the term to term rule is like 3 times the position number of 4, which is 1. But 3 plus 1 is positive 3. But we have to get 4. So what is missing is plus 1. 3 plus 1 equals to 4. So we got this. How about the second term? The second term is the term to term rule, which is positive 3 times the position number of 7 is 2. Now what is 3 plus 2? 3 plus 2 is 6. But we were expecting to get 7. So what is missing is add 1. Now 6 plus 1 is equal to 7. So our second term is 7. So we got it correct. Now, how do we use term to term rule again to look for the third term, which is 10? The term to term rule is positive 3 times the position number of 10, which in that case is 3. 10 is in third position. Okay, what is 3 times 3? The answer is 9. But we were expecting to get 10. So what is missing is add 1. When you add 1, you get 10. So you got 10. How about 13? 13 is 1, 2, 3, 4. Is the fourth term. Or 13 is in fourth position. But what is that term? What is the term to term rule? The term to term rule is add 3 times the position number of 13 is fourth position. So times 4, 3 times 4 is 12. But we are hoping to get 13. So what is missing? Add 1. So you can see in every case we're having add 1, add 1, add 1, add 1, while taking the position number into the consideration. So what do you think will be the nth term? The nth term will be term to term rule, which is positive 3 times the position number for the nth term, which is n. So 3n, then plus 1, plus 1, plus 1. So even this will be plus 1. I hope that helps. Then we have to use the nth term. We have to use the nth term to calculate the first term, the second term, the third term, and so on. So this I'll be writing somewhere here. Okay, we have 3 we have the nth term equals to 3 times n plus 1. So if I'm looking for the first term, that means n will be equal to, if I'm looking for the first term, then this implies n equals 1. So when n equals to 1, this will be, this implies 3, 1 plus 1. This makes 3 times 1 plus 1 is 2. So that gives you 6. So here you write 6. So here you write 6. And then you do for the second term. The second term implies n equals to 2. So in that case will be 3, then 2 plus 1. This makes 3 times 2 plus 1 and 3. That makes 9. So you see that? All right, next will be, now we know the process. Second term, first term n is 1. Second term n is 2. What do you guess? Third term will be n equal to what? So for third term, n will be 3. So in that case, third term will be 3, then 3 plus 1. This will make 3 times 3 plus 1 is 3. No, 3 plus 1 is 4. That makes 12. So this will be 12. So what do you guess will be the next? So from 6 to 9, add 3. From 9 to 12, add 3. So from here, this will be add 3. That will be 15. All right, that's all. Let's go to this question. Zach has some water in a jug. He pours this water into the other jug below. Draw the correct level of the water on the jug. Okay, so you have to draw them here. Let's do the calculations first. Oh, this jug is in liters and this jug is in milliliters. So two different things. So let us read the volume of this water in this jug, but that answer will be in liters, okay? So first let us calculate each small line equals to how much? So let us use this portion. We have 2 minus 1, 2 minus 1, divide by how many units are there from here? This is not counted, so it's counted as 0, 1, 2, 3, 4. So divide by 4, this will be 1 divided by 4, this will be 0.25. So from 1, you add 0.5. From 1, you add 0.5, this will be 1.25. Again, you add 0.25, this will be 1.5. And from here, this will be 1.75. And from here will be 2. Now, so we can come to conclude that the volume of this water will be, in this case, okay, so we have, this is 1. So this will be 0.75. Okay, and this will be 0.5. Okay, and this will be 0.25, and this will be 0. So the volume of water in here will be equal to volume of this water, will be equal to 0.5, but it is in liters. Okay, so we know the volume of water. Now let us pour this water into the jug below. Draw the, okay, now this jug is in milliliter. So we got 0.5 liters has to be changed into milliliters. Okay, so we know that 1 liter equals to 1,000 milliliters. How about 0.5 liters will be equal to how many milliliters? In that case, will be equal to 0.5 times 1,000 divided by 1. So 0.5 times 1,000 divided by 1. So the answer will be 500 milliliters. Wow. Okay, so 500 milliliters, we have to scale it here. We have to work out where 500 milliliters is. So this is 200. It's very easy to figure out, different from this. This was a little bit, it was a little bit hard. So this is easy. So if this is 200, this will be for sure 300. So 400 is here. So this will be for sure. This will be, see that this will be equal to your 500 milliliters. See that? Now we need to know the level, how far, the depth of how deep 500 milliliters will be. So let us make it neat. We have to make it very neat. So let us try to sketch this. We need to know the depth of water in this jug will be 500, and you have spotted where 500 is. So now let us try to draw the water level. So making a little bit neater, find the very neat. What color was used here? Guess this color was used there. Okay, this color was used there. Okay, let us try if they match, but not necessarily. Okay, so this, you draw it that way. See that? Correct. And then that is your 500 milliliters. So go down a little bit here. Come here. Go down. Go up. Up. Yes, got it. Make it a little bit transparent. Yep. Looks neat, right? Correct. So that will be the volume of water. There we go, 500. Okay. All right. So next question, quickly. Oh, wow. This angle question. Okay. Look at the right angle triangle ABC. Right angle triangle ABC. The square fits exactly inside the triangle. Okay, there we go. That is a square. What are the sizes of angles X, Y, and Z? Okay. We know that if this is a square, which is fitting inside the triangle, so we know for sure that a square has each angle equal to 90 degrees. Each angle inside a square is 90 degrees. 90 degrees. Okay, so just the concept of a square is giving me a clue that each angle there is 90 degrees. Can we compute the missing? Yes, we can compute the missing. Let me start with Z. This angle Z plus 90 plus 70 will be equal to 180. Why? Those are angles on a straight line. All angles on a straight line add up to 180 degrees. So Z will plus 90 plus 70, that gives you 180 degrees. Z plus, this will be 160, I guess, goes to 180 degrees. Okay, Z will be 180 degrees, and as 160, Z equals 20 degrees. See that? So I got Z. Z is 20 degrees. Right, now, what else can I get? What else can I get? I guess I can get x. You see, x, can you notice that this is a straight line? Can you notice that? That is a straight line. So this angle 90 plus x will be equal to 180. So x plus 90 will be equal to 180. So to find the value of x, that will be 180 degrees minus 90. That will be x equals to 90. Doesn't show well. Okay, let me delete this. X equals to 90 degrees. Yes, there we go. So x is 90 degrees. What is happening with my gadget? Okay, x is 90. Can I proceed? Nope. Something is happening with my pen. Something is happening with my pen. Can I write now? Where I can write. Okay, now. Can I get y? Why not? We can get y. Wow, we can get y. How? We already got x is 90. So x is 90. Let me change color to make some stuffs a little bit interesting. Okay, so 1 minute. I love blue. So this is x is 90 degrees. Okay, now can you notice that that is a triangle? Let me show you. Angles in a triangle. Can you see that? Can you see that? Is making up a triangle. Now you know what it means? 90 plus 70 plus y. See that? Let me write here. 90 plus 70 plus y. That will be equal to 180. Why? Because angles in a triangle add up to 180 degrees. So 90 plus 70, that makes I don't know even how to add. Okay, 90 plus 70 is 160 plus y equals to 180. Okay, so my y will be equal to 180 degrees. Take away 160 degrees. Y equals to 20. Wow, so y and z are the same. Good for you, right? All right, that is done. Solve these equations using an algebraic method. Oh, wow, this looks nice. First of all, let me try to expand brackets. You see that? 5 times 3y is 15y. 5 times negative 4 is 20. Divided by 2y equals to 7. Now, that is a fraction. Even this has to be a fraction by putting it over 1, and then you cross multiply. So this will be 15y minus 20 times 1. So it will be 1 times 15y minus 20 equals to 2y times 7. Opening the brackets, any number times 1 equals that number, so this remains the same. 15y minus 20 equals to 2y times 7 is 14y. Correcting like terms, 15y, 14y, they are like terms, so this will be 15y minus 14y. This is negative 20. When it goes there, it will be positive 20. This will be 15y minus 14y is y. Or 1y, call it. So what is 1y? This 1y will be equal to just y, and y equals to 20. So y is 20. All right, so far so good. Okay, Here we go. Oh, the keyboard. Okay. The keyboard. The keyboard container below holds 12 liters of water when full. 1 liter is 1,000 centimeter cube. The inside length and the width of the keyboard are 40 centimeters, 20 centimeters. What is the inside height of the keyboard? Okay, as you can see, the height is missing, but how long the container is 40. How wide the container is 20. So what is the height? Remember this formula which you were taught, I guess, in primary school. Volume for V equals to length times width times height. But if you look clearly, the volume here, the keyboard container below holds 12 liters of water. So it can hold, this container can hold 12 liters of water when it is full. That means its volume is 12 liters. So 12 liters will be equal to the length, 40, times the width, which is 20, times the height. But if you can see, these are liters and these are centimeters, so they don't match. So what we are supposed to do is convert first 12 liters into centimeter cube. Now we know that 1 liter is equal to 1,000 centimeter cube, is given in the question. But you have to know, 1 liter is 1,000 centimeter cube. Okay, so if 1 liter equals to 1,000 centimeter cube, how about 12 liters? Plus multiply. So it will be 12 times 1,000, 12 times 1,000 divided by 1. This will be 1200. Okay, so the volume now is 1200 centimeter cube. So here you write 1200 equals to, now everything is in centimeters, so I can ignore the centimeters and move on. This will be 40 times 20 times height. So this will be 1200 equals to 8000, okay? H, I'm looking for H, so it will be over 800, it will be over 800, and this becomes, by 4, this is 2, by 4, this is 30, that makes 15, so H equals to 15. Okay, so that's how it goes. So height will be equal to 15 centimeters. Okay, so far so good. This question is, okay, how many lines of symmetry does shape Roman 1 have? This shape here. How many lines of symmetry? Okay. Can we say there are 3? Let me check. Can I say I can cut it this way? Doesn't accept this way? What is happening? Okay, let us fit this. Okay. Can I say this equals to that? Yep. So 1 line of symmetry. Another line of symmetry, can I say, will be this? Will be this? Oops. Will be that. Can I say so? Yep, I can say. Keep going. Can I also say that it will it will be this. So 1, 2. Can I also say that? All right. Oh, yes, I can say so. So if there will be any problem, you'll come back to me and then we discuss. So how many lines of symmetry does shape? So I will say there are 3. Okay. Then what is the order of rotational symmetry for shape Lohmann 2? Order of rotational symmetry for shape Lohmann 2. Okay. Now, order of rotational symmetry, order means how many times this shape will fit into itself as it rotates. How many times will this shape fit into itself as it rotates? So the idea here is we need to get a tracing paper. We need to have a tracing paper and try to rotate this shape and see how many times this shape will rotate into. I mean, we have to get a tracing paper and see when we trace this shape on the tracing paper, then we have to see how many times this shape will fit into itself. For example, when you rotate this shape, this part will come here. So you count 1, come here, count 2, count 3, count 4, count 5, then it will go back to where it started, then that you count 6. But then, if you want to do it clearly, you need to use a tracing paper. Let me try to get a tracing paper if I can get it quickly. Okay. Tracing paper will be get that. Put it here. Okay, does it look like to be a tracing paper? Yes, we can make it a tracing paper. Yes, this looks to me as a tracing paper. So we need now to take a ruler and trace the diagram the way how it is. Take a ruler, trace the diagram. Take a ruler, make sure that you trace a diagram. Okay, so we need to trace a diagram. Okay, so take a ruler, trace the diagram, and see how this shape will fit into itself. So trace that shape, trace this part, trace this part. Okay. Then you have to draw those, kind of triangles. Okay. Let me try if I can. Good. So let me try to sketch them. Okay, one will be here. That is triangle number 1. Another one will be here. That is triangle number 2. Another triangle will be, you trace what you see on a diagram. So to look like that, no, that is not neat. That wasn't neat. Okay, so, yep, that looks convincing. Then you trace. Grab your tracing paper and then try to trace this shape. All right, so far so good. Now, after tracing the trace, after you have traced this shape, then we rotate. But before that, there's something has to be done. Okay, make sure that everything is in place. You see? Good. So now we can start rotating. You see? Whop, 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 whop. Okay. Never mind, I'm going to do it slowly. Now, the question here is, what is the order of rotational symmetry for shape Lohmann 2? Order of rotational symmetry means how many times, the number of times this shape fit into itself as it rotates. How many times it will fit into itself? Okay, let me rotate it. You have to rotate and then you come back. You have to rotate and then you go back to where you started. But while going back there, you have to keep on counting. How many times does this shape fit into itself? Adjust your tracing paper before you count. Does it fit? What is happening? Yep. Does it fit? Yes, it fits. Let's try to rotate it nicely. Oops, what is happening here? What is happening? This is to fit. Like that, and come back to there. That must fit, but I don't know, maybe the idea is this part looks to be similar to this part. Okay, so I have to count it to 1, then do that way. Try to adjust it. This was supposed to be. Let me check if I've got a very neat diagram. Okay, but anyway, because maybe when I was putting it in this software, perhaps this diagram lost its dimensions. But the idea is when you rotate, these triangles must be matching exactly, right? So, but if you have any doubt, you can just give me a little time and then I'll come back to you. But the idea is as you rotate this way, they have to fit like here. Can you see? This is what I meant, okay? So let me start now afresh. I think you got an idea, okay? As you rotate, that triangle has to come there. Then I'm wondering why they're not fitting, but that is the way how the diagram was set. Okay, so I count 1, I go here, I'll count 2. These triangles have to match. Okay, you see that? I don't know, but this is 1, 2, 3. See that? That is exactly fitting. So 1, 2, 3, 4, 5, then go back there. That will become 6. All right, so that will become 6, and I take out the tracing paper, delete that, but I guess this diagram lost measurement. I mean, lost is something like its scale. Okay, so lastly but not least, we have this: using a ruler and a compass, construct the bisector of angle B, of angle ABC. Now, the bisector of an angle is any line that passes through the center. So we have to construct that line using a ruler and a pair of compass. Okay, so how do we do that? So we need to get a ruler and compass. So the ruler, let me grab my ruler. Okay, I have my ruler here. Yep, I think you can see that. This is my ruler. And let me check for, yes, this is my pair of compass. Now, let us put the ruler somewhere here. Okay, so we go back there. Now, we need to construct what we call the bisector of an angle. We want to cut this angle here, cut it into two equal parts using a pair of compass. So what we do, we take you just take your compass, take this compass, put the sharp point here, put the sharp point here at the angle itself, and then set your pair of compass in such a way that when you open it, we try to open it like so, then cut this line here, cut it here. I mean, cut it like this, make an arc somewhere there, and come and cut this line here, make an arc. Can you see that? Then take out your pair of compass and put a label, put a mark somewhere here. Put a mark somewhere here where you have cut these lines. Okay, now next time is to bring back the pair of compass. Bring back the pair of compass and stand here. Okay, at that point, and then adjust your pair of compass so that you can be able to make another arc somewhere here. That looks so dark. Okay, so let me adjust my pen. Put it. Okay, so make an arc somewhere here. Make an arc somewhere here. Somewhere here. Okay, can you see that? And then do not disturb your pair of compass. Come and stand at this point. And then cut this previous arc. Cut it. Cut it like that. See that? Then take out your pair of compass. Take it out. Then it's time for you to label this point here. Label this point by using a dot. See that? Then you are going to connect this point and this point, which is on the angle itself, using a ruler. Take your ruler. Take your ruler. Put it here. See that? Take your ruler, put it there. Then, after putting it here, then turn your ruler in such a way that they will make a straight line. Can you see that? The ruler should be helping you to draw a line from this point to that point. See that? Now you take your pencil, draw a line from here to there. Now that line which we have drawn is what we call the angle bisector. So this is your angle bisector. We can label it. This line is your angle of bisector. This line here. Angle bisector is this line which I have drawn. See that? That is your angle bisector. All right, we are still moving on with the same tools. This tool. Okay, bring it back. Can close it. Okay. And close it like so. Close it. Okay. Wasting time. Take another one from here. Yep, here we go. Now, the line CD is drawn above. The line CD, this line CD is drawn above. Use a ruler and compasses to construct the perpendicular bisector of CD. Okay. Now this time we are given a line, and then on this line we are supposed to draw what we call perpendicular bisector. Perpendicular bisector is any line that cuts this line into two equal parts. And it should be able to make 90 degrees here, 90 degrees there, 90 degrees here, 90 degrees there. Now the question is, how do we construct that line? We need the same tools. We need the same tools to construct the perpendicular bisector. We need the same tools. Okay, how do we do this? Okay, step number one is take this tool, put it here. Let me show you clearly. Take this tool, put it here. Or you can turn it around like this and put it somewhere here. The sharp point should be put somewhere here. Or you can do it this way, set it this way. I think this will be better. And the sharp point should be somewhere here. Then extend or open this pair of compass to at least beyond the middle of the line. See that? And make sure that while extending, it should fit like that. Do you see what I'm doing? I think yes. Okay, so once it is set like this, then what we need to do is set it this way. And then we are supposed to draw an arc somewhere here. Draw an arc somewhere here. And do the same thing somewhere there below the line or on the left-hand side of the line. See that? Do that way. See that? Okay. All right. So once we are done, once we are done, then take this pair of compass. Don't disturb the pair of compass. Take this pair of compass, stand here. Can you see that? And turn around your pair of compass so that you can come and cut this arc, and then turn around so that you can come and cut that arc there. Can you see that? Then you are done. Take out this, take out that. Then put a dot somewhere here. Put a dot somewhere there, somewhere here. Now, what you'll be surprised is that when you take your ruler, you'll be surprised that the two dots will be on a straight line. Can you see that? You'll be on a straight line. This is done, so you can remove it. So this is the surprise which you'll be able to see. So now this surprise is that will help you to draw a line using a pencil like that. See that? Good. Now, let me adjust my line. Just went out of the point. You see that? Okay. Now this line is what we call the perpendicular bisector. Why? Because this angle this angle here is 90 degrees. So massive. This angle here is 90 degrees. And that is what it means by perpendicular. Okay, now another surprise is that why do we say a perpendicular bisector? Because this line has divided the line CD into two equal parts, and you can take your ruler, measure, and measure these two portions. You see, this is exactly somewhere around 2.3. And when you do the same thing here, get the same thing. Okay, so this was, that is 0, 1, 2. That is more than 2.3. This will be 2.5. So even here will be exactly 2.5. All right, so far so good. So take out your ruler. We don't need this ruler. Then take out that. And there is your perpendicular bisector. So here you label, this is your perpendicular bisector. Perpendicular bisector. Perpendicular bisector. Okay, that line is your perpendicular bisector. Let me see if I've got the last question. Okay, this will be the last question. Reflect shape P in the dashed line. Okay, reflect shape P in the dashed line. Okay, this is easy. So step number one, we needed to label the vertices which make up the shape. So these are the vertices. These are the vertices here, the corners which make up the shape. And this corner, which is on the dashed line, because the dashed line here is known as the mirror line. You see, the dashed line, the dashed line is what we call the mirror line. So this point on the mirror line will not move, will stay here. Okay, will stay here, but this point will move. One box, it is one box down, so it will move here. This is two boxes down, so it will be two boxes up. And this will be one box down, so it will be one box up. Two boxes down, so that will be two boxes up. And then you take a ruler, you join this point to this point, to that point, to that point. There is your image. See that? So this is your image. And this image has to be labeled the new shape as Q. So this is the new shape, which will be labeled as Q. Okay, that looks to be very, very big. Okay, so here we'll label as Q. What else? Translate shape P 3 units right, 4 units up, label the new shape as R. So, okay, we start moving each point on shape P, 3 units right, 4 units up. So start with this point, for example, this point here, move it, okay, move this point, okay, move this point 3 units, this point here, move this point here, move it 3 units right, 4 units up. So 1, 2, 3, 1, 2, 3, 4. So that dot will be there. This point will be 3 units right, 4 units up. 1, 2, 3, 1, 2, 3, 4. So that point will be there. This point will be 1, 2, 3, 1, 2, 3, 4. That point will be there. This point will be 1, 2, 3, 1, 2, 3, 4. This point will be 1, 2, 3, 1, 2, 3, 4. Okay, so I'm done. And then I connect those points using let me check if I can get, I love blue color. So blue color comes to be here. So connect this point to this point, to that point, to this point, to this point to get a new shape. See that? And we have to label the new shape as R. So we label the new shape as R. So this will be R. Let me check that. All right, so we label this new shape as R. This will be R. All right, so far so good. Translate shape P3 slide, label the new shape as R. I'm done. Work out the area of shape P. Okay, area of shape P. Shape P is occupying how many boxes? 1 box, 2 boxes, 2 halves. So it will be, area will be 1 box, 1 box, plus the other box, plus the 2 halves boxes. So this will be 2 plus 1, this will be 3. So it will be 3 square units. These are boxes. These are boxes which are contained in shape P. All right, so far so good, and that marks the end of this worksheet to my Form 1 students who are currently at home due to Corona holiday. So until next time, bye-bye for now. Bye. Okay.